Page 153, number 12. In part A of number 12, they ask you to show, we have an isosceles triangle with constant side lengths of the two congruent sides being S and the angle in between being theta. And it says show that the area of the triangle is 1/2 S squared sine theta. In class, I showed some people I showed a pretty fancy way to get this, but I thought of an easier way. If you take the formula that you learned in pre-cal, 1/2 AB sine C for the area of a triangle. Since the sides are S and S, you can put S and S, and then the angle is theta. So this is much quicker and easier. 1/2 S squared sine theta. So that's part A. Part B, the angle is increasing at a rate of 1/2 radian per minute. So that means d theta over dt is 1/2 radian per minute. It asks us to find the rates of change of the area. So we want dA over dt when theta is pi over 6, and then again when theta is pi over 3. So I'm going to take the formula and differentiate it with respect to time. Now this one is unusual because 1/2 S squared is a constant. They said that these two sides were constant lengths of S. So in other words, the triangle could be opening up more, but these are still S and this is still theta. So this is a constant, so you can treat it as a constant coefficient. So when I take the derivative with respect to time, I'm going to treat this as a constant, so that would just be the coefficient. And then I take the derivative of sine of theta, which would be cosine theta d theta dt. They told us what d theta dt was, and they tell us what angle they want us to put in. So dA over dt would be 1/2 S squared. Cosine of pi over 6 is square root of 3 over 2. D theta over dt is 1/2. So this would be S squared times the square root of 3 over 8. The area would be measured in, let's see, I'm looking to see if we have units. We don't have units for the side, so it would just be so we would just have to say square units per minute. And then you could do the same thing with the pi over 3.